Biomass consists of plants or plant material that can be burned to produce energy. That word bio, of course, means life. It's a living material. We can get biomass from wood chips, straw from agricultural waste, and some other stuff, which we'll talk about at the end. Make a note here of this waste to energy, or WTE, waste to energy. We're going to talk about that next. So waste to energy is related to landfill gas. In a landfill, there's a lot of organic material. Can be food waste, there's also paper, pieces of wood. All of that is organic, and it gets buried under this deep layer of soil and debris, and gets buried so deeply that oxygen doesn't get there. And who lives in places without oxygen? The ancient anaerobic bacteria. These guys, anaerobic bacteria, they're the oldest life form. We have them in our guts, in the guts of animals. We use them in sewage treatment plants, and they like to eat organic matter, especially buried deep in a landfill. And when an anaerobic bacterium eats organic matter, it gives off CH4, carbon, hydrogen, 4, as a byproduct, and that is methane. So plants take in carbon dioxide and give off oxygen. Humans take in oxygen and give off carbon dioxide, and anaerobic bacteria give off methane. What is methane? Methane is basically natural gas. So people early on realized, hey, we could capture this methane that the bacteria are giving off, and we could use it in any kind of power plant that would normally run on natural gas. And so that's what these waste to energy plants do. They capture the biogas, the natural gas that's produced by these bacteria, and they use it in burners to turn generators. Other places that use biogas are sewage treatment plants, although that's less common, and also, and this is sad, animal feedlots. They are truly nightmarish places, but that's a separate topic. They produce a great amount of sewage, and the anaerobic bacteria produce methane in that sewage, and so feedlots often have biogas plants in them. Now, when you burn biogas, many people argue that it's probably carbon neutral, because, that is, you're not giving off more carbon dioxide than you originally took in. And people say that because you're taking plants who originally took carbon dioxide from the air, you're burning them. Okay, they now give off carbon dioxide, but it's net zero. It's no more than they originally removed from the air. There seems to be some debate about that, so I will leave that up in the air. Some people can argue that it's carbon neutral, and other people argue no, it's not. Another thing to think about, and remember, there are always trade-offs whenever we're doing renewable energy of any sort. A trade-off that can happen with biomass, in addition to the whole carbon question, occurs if there are any kind of synthetic chemicals in this material. So maybe you're using wood waste or agricultural waste, and herbicides and pesticides were used in that material. Or maybe there's some kind of heavy metal in that material. Well, those kinds of compounds give off dioxins and other toxic material when they are burned. So that's the danger to biomass. There's another kind of pollutant that comes from burning biomass, and it's called PM2.5, which I list down here next to the words wood smoke. PM is an abbreviation for particulate matter. And particulate matter is just any kind of particle that's floating in the air. So it's an aerosol, which means it's floating freely in the air. And scientists rank these particulates based on what size they are. The bigger particles are 10 microns, or millionths of a millimeter. So PM10 is 10 microns in diameter, and as this diagram from the EPA shows, that's about the size of a human hair. I'm sorry. A human hair is 50 to 70. A PM10, there are a bunch of PM10s in a human hair. Okay, so if you breathe in PM10, like it's ragweed season and you breathe in pollen, you'll cough a lot if you have allergies, but you can cough that out of your lungs and get rid of it. Smaller particles are PM2.5, so they are 2.5 microns in diameter. And the problem with those guys is they are so small, they get down into the alveoli in your lungs, those little air sacs in your lungs, and they're so small that you cannot cough them out. And they're cumulative. So the more wood smoke or other biomass you breathe in, the more those particulates accumulate in your lungs. They cause asthma, and it has been documented that they cause cancer. In places in cities where there is a lot of some kind of exhaust being given into the air that is high in PM2.5, we find cancer clusters, especially, and lung cancer, other kinds of cancers, especially among children, and we find asthma clusters. So this is definitely a trade-off to be aware of.